Do we have evidence that SARS-CoV-2 has mutated into a form that's more easily transmissible? Maybe we do. We're going to look at that today. Hello, everyone. This is Dr. Chris Martenson with your daily update for the honey badger virus today, being May 5th, Cinco de Mayo 2020. This is day 103 of our reporting series here, calling this one Mutation. And I'm still going to give up on that tradition of sort of reporting all of the cases and sort of pouring through what they might mean. I think we're seeing a lot of evidence. We are seeing a lot of evidence that curves have been flattened, that the NPIs, those non-pharmaceutical interventions, the social distancing, the lockdowns, the stay-at-home orders, all of those things have had a great impact on reducing the spread of this disease. Now, I came across this really interesting thing on Data is Beautiful over at Reddit, and what's being tracked here are the daily total deaths per day in Spain starting in 1941. If you can't see that, we're in the year 1960, 1965 right there, 1970. So we track along. This includes flu seasons that are coming along here. This includes periods of civil unrest and turmoil. This includes everything that's happened in Spain's history, and here are all the deaths that are recorded. Now we're into the year 2005. Here we're coming up on 2015, and here we are with COVID. Look at that. It stands out amongst all those many, many decades of history. And let me see if I can freeze this back here. Nope. Yeah, let me freeze it way up here. Yeah, anyway, that's not working out. But look at that spike you see right there. These are all the other decades that Spain has been through in its entire history, and it's never experienced anything quite like that. I think that's pretty gripping evidence that this is not the flu. Here's another way we could see excess deaths. This is COVID excess deaths here in versus a typical flu season. And again, these are modeled. These are the modeled deaths that the CDC might put out here. But these are the actual COVID deaths that we're seeing here. And this is for Italy over here. Deaths versus a typical flu season. Look how beautiful, what a perfect model that is, right? Just a nice little bell curve there. But these are the actual deaths here seen for COVID. So again, very much not the flu. And I think excess deaths, that is the right way to look at this across any country. Because again, as we mentioned, what's being called COVID? Are you dying of COVID or with COVID? And there's all these people out there really unhappy with the idea that too many people are being recorded as having died of COVID. Listen, take all of that away. COVID has done a number of things. It's transformed our societies. It's killing some people, but it's saving other people. What's the net effect? And what do I mean by saving other people? Well, that's because we're all in lockdown. We're generally not engaged in all those risky things like traveling, driving cars, walking down flights of stairs, other things and ways that people tend to get killed, right? Mostly on the roads would be the number one way. So people aren't driving. I know my car is not, I haven't filled, I don't even know when the last time I put gas in my car is. In fact, as I was walking by today, I looked down at my rotors on my brakes, because they always gleam at me. They're rusty. I got rusty rotors right now. I got to drive it around and tap the brakes just to get the rust off. I mean, it's crazy. And because I'm not driving, I'm less at risk. And that goes true for a lot of people. So when you look here at the total number of excess deaths that you see in all these countries, this would be the expected number here on these dotted lines, right? And anything above that, and this is weekly deaths, confirmed weekly deaths. So in a given week, there are many excess deaths here in France, many excess in Spain, which we just looked at. England and Wales still trending up on that one. The Lombardy region coming down now, but still way above the trend line, which would be way down there. New York City still way above its trend line right here. Netherlands coming down, but still way above expected trend line. Belgium, same deal, way above. Sweden, way above here, okay? Istanbul, Turkey, way above, okay? So this just confirms that COVID is the real deal, and it's pretty lethal. Now, when we look at the United States more specifically, we can see here, United States fully has a third of all the cases in the world. Now, these are the reported cases. Of course, we don't know how many people are unreported, and still, I'm surprised that I haven't seen better and more complete serological data. After that flawed Stanford study came out, there was another flawed study out of Germany, flawed tests, all of this and that, and flawed interpretations in the case of the Stanford study. But I was expecting to see more and more of that coming out, and I haven't seen a lot of that. So I'm waiting for some more better data to come out of that. But still, you can make of this what you will, but the United States is a third of the world's cases and is only 4.3% of the world's population. So that make of that what you will, but I think you could easily say that at least this country here isn't really doing that hot of a job at containing COVID. And as well, we would see that Italy is not even on this chart. Yeah, too bad. But Italy has more than its fair share as well. Okay, now we're going to talk about a reason why that may have happened, why that came forward. Again, I have to remind you of something. We talked about this yesterday, the difference between mutations and an insert. This is a mutation where a single nucleotide gets swapped out for another one. In this case, a T became a G. And because the T became a G, this would read out and give you a different amino acid in the protein that this is coding for. This is an insertion where everything's the same except there's a whole new block of letters that have been put in, and then everything continues on as normal after that. So this is when we talk about a mutation, we're talking about these sorts of things here where this G flipped from a T, okay? And as well, when we talk about mutations, let's talk about them because, if you watch the movies, a mutation is always a bad thing. That's not what we're talking about here. So let's define this really quickly. We have the wild type or the original type of virus out there, and then a mutation occurs. And one of two things happens with that mutation. Either nothing, it's completely benign, and it has no impact whatsoever, in which case nothing happens. Or that mutation is going to either make this virus to be more transmissive here or less transmissive. Now, selective pressure being what it is, this one is not selected for because it's less transmissive. Selection is going to clearly favor the more transmissive mutation. And then once it's more transmissive, well, it's either less lethal or more lethal, or I guess I should put the third one down, which is just as lethal. But after it's more transmissive, it might pick up a mutation, or even that same mutation might make it less lethal or more lethal. Over time, if you get to be too lethal, that's going to actually, surprisingly, make this virus selected against. Sorry, let me back that one up. I put the X in the wrong spot. It's going to make this selected against. Why? Because it's kind of like with Ebola. If something is really wildly lethal, people have a way of going about avoiding that and managing to evade that particular virus. And more serious measures will be undertaken to resist that. So the more lethal it becomes, I think that there's a good chance that that'll get selected out, selected against. And as well, if you're too lethal, you end up killing the host before that host has a chance to spread it along. I mean, a really, really dangerous thing is something that has an asymptomatic transmission period, and as well, its lethality is pretty high. That's a bad combo. But at any rate, so this is a little less clear. This particular effect out here, is there some magic threshold of lethality that will make this thing be selected against? But at least here, this is very clear. The less transmissive something is, the more it's going to be selected against. And something is more transmissive, this just makes a lot of logical sense. Hey, it's going to spread to more people more quickly. So in that line, there was a paper that came out. This is a preprint, so this has not been peer-reviewed yet. We're going to put our usual grain of salt on this when we look at this. Who did it come from here? This is the lead author here coming out of Los Alamos National Laboratory. This was a bioinformatics look at this particular study we're going to look at here. We've got people here from Sheffield, and Sheffield shows up prominently in the results down here because they actually had access to data from Sheffield that they put into this, which is very cool data. At any rate, they were looking here at something, and their conclusion, their headline is Spike Mutation Pipeline, we'll talk about that in a second, reveals the emergence of a more transmissible form of SARS-CoV-2. So, a more transmissible strain. They're saying that they think the mutations come forward, and it's led to this up here. So, what did they come up with? Well, without getting into the whole background of this whole thing, I read the whole paper. What they did was they went and looked at all of the strain data that was out there. And in particular, they were looking for changes in the spike protein, because they know that if you have a change in the spike protein, that can either make something more transmissive or less transmissive. That spike protein is the binding part, and it's also the part where there might be a mutation that allows, this thing to gain entry into the cell more easily, as in that PRRA insert. That is something that gave and conferred additional ability to get into the cell, it looks like. So with that said, they were looking out there for mutations, but these wouldn't have been inserts. These would have been point mutations, transposition and swap things like this, the T becoming a G. So they're looking at all that stuff, and what did they find? Well, this when they peered through that database, they discovered something that stood right out. It turned out, when they say here, when we embarked on our SARS-CoV-2 analysis pipeline, our motivation was to identify mutations that might be of potential concern in the SARS-CoV-2 spike protein as an early warning system for consideration as vaccine studies progress. We did not anticipate such dramatic results so early in the pandemic. So they weren't, usually these sorts of mutations take a long time to develop, but they found one that seemed to have popped out right away and showed up in Europe. Okay. This approach revealed that the viruses bearing the mutation spike D614G, this is this D amino acid becoming a G amino acid. This, and at the 614 position. Okay. The D became a G. So arginine became a glycine. They are replacing the original Wuhan form of the virus rapidly and repeatedly across the globe. So they say here they don't know what's driving the selective sweep, and they're talking about that selection that selects for one viral type versus another, one serotype or clade versus another, nor for that matter if it's even indeed due to the modified spike and not one of the other two accompanying mutations that they found that came along with that. And this was called the G-Clade haplotype. It's a type, so the genetic type. So this one they found it had this D614G mutation. It had a couple other mutations that were deemed to be not important because they're way out in other parts, and they thought the one in the spike protein might be the more important of them. Hey, maybe that's the case, maybe not. More research needed. The spike D614G change, however, is consistent with several hypotheses regarding a fitness advantage that can be explored experimentally. D614 is embedded in an immunodominant antibody epitope. So, immunodominant antibody epitope. Immunodominant. So it's the dominant place of your immune system is going to target an antibody. The antibody epitope. The epitope is the surface of the protein on the spike that your antibodies are going to target. That's the epitope. Like, yeah, we're going after this little region right here, and the antibody binds onto that protein there, hopefully neutralizing it. So D614 then is embedded in an immunodominant antibody epitope, recognized by antibodies isolated from recovered individuals who were infected with the original SARS-CoV. I'm not sure how meaningful that is because SARS-CoV and this one are quite different. Maybe it is. This epitope is also targeted by vaccination in primate models. So at least they're saying, hey, this area of the spike protein, pretty important. And that's where your antibodies tend to target it. And unfortunately, this D614 is embedded right in that area. Thus, this mutation might be conferring resistance to protective D614-directed antibody responses in infected people, making them more susceptible to reinfection with a newer G16 form of the virus. So let me decode that. You get this D614 virus. It's wobbling around your body fights it off, develops an antibody response, targets antibodies, they're neutralizing. That D614 variant of the SARS-CoV-2 is now neutralized. Yay. But then you get infected with the G614 version. And the hypothesis they're putting forward here is that it torques that spike protein a little bit. Oops, it has a different shape. That lock and key antibody attachment no longer works like it used to, or it works poorly, or not at all, or it's diminished in some way. And all of a sudden now you might be susceptible to reinfection with this new form. All right. I think if that was true, we'd actually see a lot more reinfections than we have seen, but I'm going to present some other data that says maybe this is true too. We don't know yet. All right. And so, and again, this may have something to do with this ADE thing, the antibody-dependent enhancement that we talked about, that we really hope is not a part of the immunological response to this honey badger virus, because that's nasty, that ADE stuff. All right, so here's the data they came up with. Blue, here's the two clades. Here's the dominant, the original form, classic of this form. Not classic's what they were calling SARS-CoV classic. What's a different name? So the original strain of this thing was this D614. That's in orange. And then in blue, you have the G-Clade, the G614. So what they're showing here is that first thing to come out of Wuhan was this D bit, this D-Clade, and then this G-Clade, when it takes over and it becomes the dominant form, right? And so that would suggest that it wasn't just that this G form got there first, because it looks like from this chart for the whole world that actually it was the D type that was there first. At any rate, it comes in and then it takes over, and that would suggest that it's more transmissible because it's the dominant form that is spread around. This is the whole world, but breaking it down, you can see the same dynamic in Europe happening here. Let me see if I can make this a tiny bit bigger, because maybe that'll hit a little bit. Can't hurt, right? All right. And you see here in Canada, they had this D type, and then boom. In North America, then this G type came along and clearly was dominant and became dominant. Italy has only had this type. It looks like this is where that type may have developed in Italy, the G type, and they had a bad run of it, of course. And it was the Italian results that were making me think, God, remember if you were watching this series a long time ago, a few months back, I was saying, what is going on with Italy? Do they have a different type of this virus? It would not surprise me because of the speed with which it overtook their populations. And so we don't have any data in here to suggest, I have some data that suggests maybe, but we don't have clinical data to support the idea that the G-type has a worse clinical outcome. But we would have data to suggest that if you have this G-type and the G-clade that spreads more easily, then it could more easily overwhelm your hospital system, and that leads to worse outcomes for people. That seems to be what happened in Italy. But again, in Germany here, down at the bottom, we see both the types, and it goes away for a while. Germany has really had their hands on it, and then this G-type just explodes across their scene here. Out in Washington State, they had this early version here, the D-type, and then later the G-type came on board. New York, bad run with the G-type and had very bad results in clinically, which Italy shared. And you wonder why the United States in general has been having so many deaths compared to other places in the world. Well, they really hit hard with this G-type. So that's the theory. This is what hasn't happened yet is that nobody has managed to culture the G-type, show that it infects cells in vitro any more readily or virulently, and transmits more easily, or run the animal models. That would be the gold standard of the scientific circle. You would see the observation, then you would find ways to test it, and then if those tests came back and validated that, then you would lock that up and say, yep, this G-Clade version absolutely transmits more readily. But this is the kind of data, if you see it showing up like this, it supports the idea that there is a strain that is more transmissible. And also, higher viral loads, a possibility with the G-Clade. I remember I said that the Sheffield was going to come into play. They had here this number of patients right here, which is 447, if I add those two numbers together, patients in Sheffield that they were able to run these tests on and see if they had either the D or the G-Clade in their systems. And so when they ran those, This is the way this chart is to be read. These are PCR cycles, and a cycle is a full turn of this machine where you put your sample in and you're trying to detect if that SARS-CoV-2 virus is in there, and you have to cycle the PCR machine. And the fewer number of times you have to cycle it before you're able to detect that virus, it says the higher the viral load. Let's imagine, I'll just make some numbers up, that the machine can detect it once you get to like 1 million copies. But if you start from 10, and it goes from 10 to 200 to 800 to 1600, and it's going that way, it takes a number of cycles before you get to 1 million. So at any rate, the fewer the cycles, the higher the viral load. So lower values equal higher viral loads. And here you can see that the G-Clade was all the way down here. They had one sample run that had only required 12 cycles. But the mean of this whole thing was this black bar here. And the mean of this whole thing is this black bar here. And apparently the difference between those two was statistically significant, with a p-value of 0.003. So at any rate, supports the idea that they're higher viral loads. And of course, a higher viral load comes in with a worse clinical presentation. So that would, but at least also a higher viral load would suggest that it's more easily transmissible, because somebody who's got a lot of virus in them is going to transmit that more easily than somebody with less virus in them. So at any rate, that's the data we've got there. And then the idea of, as well, do we have these second infections? A lot of articles like these coming out now. This one in Bloomberg on May 1st, false dawn, recovery haunts virus survivors who fall sick again. It had been over a month since Mirabai Nicholson McKellar was infected with the coronavirus, and the 35-year-old filmmaker thought she was on her way to recovery. Then the shortness of breath came back, followed by chest pains. A visit to the emergency room and a second test for COVID-19 gave another positive result. Just 3 days earlier, she'd been cleared by health authorities in Australia's New South Wales state and was allowed to end her home quarantine after going 72 hours without symptoms. So that might fit with the idea, and we don't have any data for this yet. We don't, haven't seen her test results, if they even did the genotyping off of her. But it would be very damaging if we discovered that she had gotten the D type and had recovered, and then later got infected with the G type or some other mutation. We don't know, but that's what we're worried about, is a new serotype emerging. Her experience adds to a growing number of reports of patients appearing to have a reactivation of symptoms, testing positive again, or even potentially being reinfected. Such incidents don't align with the generally accepted understanding of how virus infections work and spread. Well, that's what you get with a gain of function, sort of boost, I guess. Maybe that's, if you create a really, beast of a virus, maybe this is what happens. I don't know. This so-called false dawn phenomenon is puzzling health experts as they try to come to grips with the mysterious pathogen that emerged only 5 months ago. And oh, by the way, after only emerging 5 months, it has now been detected in cats, tigers, dogs even to a weak extent, ferrets. It's amazing that this virus that supposedly came from a natural reservoir didn't just make a species jump, but suddenly is able to infect all sorts of species and came out of nowhere all at once. Real mystery there. Or came from a lab. Solving the puzzle will inform a broad range of challenges, from the development of an effective vaccine to how soon governments may be able to safely end lockdowns to allow normal life to resume. More immediately, the situation is taking a personal toll, making the journey of recovery a complex and frustrating ordeal for some of the more than 1 million survivors of the pandemic. So far, there hasn't been enough research to conclude why symptoms seem to reemerge in some people and whether they experience reinfection or if the virus persists for weeks. And by the way, lots of viruses do persist, and so that would not be super surprising if we found that out. I mean, HIV persists, chickenpox viruses, the varicella viruses, they persist sometimes for a lifetime. You get chickenpox as a kid, and then when you're an older person, you get shingles or something like that, right? One possibility is that COVID-19 causes blood clots that may cause potentially dangerous complications unless treated with... No, that's not a possibility. We know that's the case. So I'm not sure how that possibility ties in here. So let me just cross that one out. At any rate, here's an idea that reinfection may be a possibility. And then just yesterday, May 4th, this came out in NBC, fever, fatigue, fear. For some recovering COVID-19 patients, weeks of illness, uncertainty. For some, recovering some. So this is clearly not everybody. Kate Porter has had a fever nearly every day for 50 days. She can't shake the extreme exhaustion that hit when she became infected with the coronavirus nearly 2 months ago. The longevity of her symptoms are unlike anything she's ever experienced. I know it sounds crazy, she said, but is this permanent? Since her diagnosis, Porter, 35, has been in her Beverly, Massachusetts home with her 12-year-old daughter, Adria, who's also had symptoms of COVID-19. I feel great one afternoon, and I think I'm going to read, I'm going to do laundry, but inevitably the fever and fatigue return. It happens repeatedly. It's like a mind game. Continuing, Andrew Dumont, 32, of Seattle, has also tested negative for the virus after a previously positive COVID-19 test 2 months since first falling ill. 2 months. Dumont still suffers from numbness in his limbs and shortness of breath, prompting 2 visits to the emergency room twice in the past week. CT scans and lung x-rays show no additional infections, and he says it's really scary because you're just kind of left at home by yourself, essentially trying to treat it. So this idea, these are anecdotes again, but we'll want to collect the data, we'll want to see what's coming in, but it's at least supportive of the idea that if there are 2 strains, we need to know now, can you catch strain 1 and then can you catch strain 2? So we don't know about that yet. We don't have a lot of data. We've only got a handful of anecdotes like this, but these are troubling even if these aren't reinfections with a second strain, because these speak to the idea that the disease progression of this is something we really don't understand and that it can be a real honey badger of a virus and very, very tough to eliminate. So the conclusions for today, hey, excess deaths, they are the best way to track COVID. And by the way, they will tell you very clearly this is not the flu. Remember the Spanish data with that big spike? The U.S. has 4%. 4% of the world's population, and we're just going to have to fix that right there. I think it's 4.3 of the world's population, and 33% of the COVID-19 cases. You make of that what you will. The D614G mutation, it seems to, question mark here, confer selective advantage to COVID-19, which in plain speak means it makes it more transmissible. Many people struggling with cases lasting 30, 40, 50 or more days. Even if you get it and you're on the short end, it's still a long, ugly disease. I am going to avoid getting it as best I possibly can because I don't want this thing, and I'm going to do my best to avoid it and just wait this thing out until we either get a more effective treatment. And by the way, I'm still very hopeful that we're going to find that there is some cheap and easy, cost-effective, off-the-shelf compound like ivermectin, like hydroxychloroquine, or something like that can help diminish the viral load early in the cycle. As well, we'll probably come up with some awesome other treatments, maybe monoclonal antibodies, other things like that may be good treatments going forward. Remember, I need you to resubscribe and hit the like button. You hit that like button right down there. The resubscribe is going to be right over here. And the reason is that we still get these all the time. People telling us that they were unsubscribed from this channel, as well as unsubscribed from our Twitter feed, which is @ChrisMartinson. So do all of that, and as well, plant a garden. I think, I've been hinting at this for a long time, but the food shortages we see developing are clearly something that's going to hit us all, and access to good, fresh fruits, vegetables, and other things that you can grow yourself is going to be a wonderful addition to your life. Plus, it's very healthy and fun to grow things outside. All right, that's all I have for today. Thanks so much for listening. We'll be back with you tomorrow. Bye-bye.
Hi, folks. Adam Taggart, co-founder of Peak Prosperity, here with good news. In his daily videos, Chris often refers to the book that he and I wrote, Prosper: How to Prepare for the Future and Create a World Worth Inheriting. It presents a practical model for living with greater resilience, and those who read it and followed its advice were much better prepared for the coronavirus outbreak than the average household. Given its heightened relevance to the turbulent times we now find ourselves in, Chris and I want everyone to benefit from this book's formula for better, more secure living. So we're giving the book to you for free. To get your copy, simply visit peakprosperity.com/freebook. We think you'll find this an extremely valuable and inspiring resource for the current COVID-19 outbreak and for being well positioned for any kind of crisis that comes our way in the future. Thanks for listening, and happy reading.